Warm wishes and greetings, friends. Today we are going to see about the video lecture on a simply supported beam with the 2-point load. This is 1-point load which is at a distance of 2 meters from this support A, and another point load of which is 10 kilonewton which is acting at a distance of 2 meters from the right end support. So this left point I called as A, this is B, C and D. Now, what about the reaction for this simply supported beam with 2-point loads at the same distance of 2 meters from the left and right hand support and of magnitude 10 kilonewton. So here you can see the point C and D will not carry any shear force. Shear force will be 0. So because the reaction at the support A and B are 10 kilonewton upward and 10 kilonewton upward reactions. So due to this, the shear force at A is 10 kilonewton positive shear force to the left of this point load, that is at C. Then coming to the left of this point, you are getting plus 10 kilonewton, and if you are taking the right of the point load, 10 minus 10, 0. So the 0 shear force right occurs at C and D. So if you take here, right, so the shear force value will be negative because right of point load getting left of section downward is negative. So 10 kilonewton from C to B. So you are getting a shear force of positive 10 kilonewton from A to C and 0 between C to D, and negative shear force of constant value of 10 kilonewton which is of negative shear force. So between BC we can observe that the shear force is 0. So here for a simply supported beam with a 2-point load which is of same magnitude 10 kilonewton, 10 kilonewton acting at the same distance of 2 meter and 2 meter from the left and right hand, right? So shear force is 0 between C to D. And coming to the bending moment diagram, so at the support A it will be 0, similarly at the support B it will be 0. So at C, so you are getting 10 into 2, 20 kilonewton clockwise moment. So plus 10 kilonewton meter. So here also you will get, right? So at this point you are getting 10 into 2, 20 kilonewton meter. Here also 10 reaction, here 2 meter, right? It's an anticlockwise positive. So it is again 20 kilonewton meter positive value. So it will be off, right? So from 0 to 20 between A to C, and from C to D it will be a constant value. Then from D to B it will be taking from maximum of 20 kilonewton to 0 value. So it will be of the triangle between this portion and this portion, and it is having a constant bending moment between C to D because the shear force value will be 0. So between C to D, the beam is subjected to the pure bending. There is no shear force. That means, so this is an example where the pure bending occurs between the given loads on a given simply supported beam. You can see the bending moment is constant, right, which is of maximum value of 20 kilonewton meter, sagging moment, positive moment. So this is an example where the pure bending will occur. So the pure bending equation we have drawn, that is M by I is equal to F by Y is equal to E by R. So in this region C to D, so this equation is applicable because there is no shear force. Due to this no shear stress, only the bending moment which causes the bending stress. So but between A to C and D to B, so definitely, so there is a shear stress as well as the bending stress. So this is an example where the pure bending occurred for a simply supported beam with a 2-point load of 20 kilonewton. This 10 kilonewton is acting at C and D. So, so where the pure bending occurs, there is no shear stress will be occur in between the C to D. So this is an example where the pure bending equation occurs. So this is about the simply supported beam carrying 2-point load 10 kilonewton, which is acting the same distance of 2 meter from the left hand support and right hand support. So due to that, the maximum shear force will occur right between A to C and C to B. So there is no shear force between C to D. And in the case of bending moment value, so 20 kilonewton meter which occurs between C to D, that is constant value. So this is about where the bending moment of maximum value between C to D. So here between C to D there is no this shear force, that means no shear stress, only the bending, pure bending will be taken place. So this is an example where the beam is subject to only the pure bending, so there is no shear force. Thank you very much for patient listening, and God bless. வாழ்க வையகம், வாழ்க வளமுடன்.